Today we will solve a linear programming problem. First of all, what is linear programming? Linear programming is the branch of mathematics that deals with the inequalities, that is forming inequalities and solving them. There are two ways to solve a linear programming problem. First one is graphical method. In graphical method, we solve the problem by using graphs, and the second one is simplex method. In simplex method, we solve the problem by means of a matrix. Now let's move towards the question. Uh, we have the question. There are in linear programming there are three parts of a question. The first one is the objective function, second one are the constants, and the third one are the non-negativity values. Here we have the objective function z equals to 2x1, which is a maximized function. We have the constants. We have two constants. The first one is 3x1 plus x3 greater than equals to 12, and the second one is 2x1 plus 2x2 is greater than equals to 12. And we have the non-negativity values, that is all the variables are greater than equals to 0. First step in simplex method is making the constants which are inequalities into equalities. Here we can see there that these are inequalities. The constants are in inequalities, and we have converted them in equations by means of a slack variable. Slack variable are those variables which we use to make inequalities to make equations. Here we have used s1 to make this constant equation, and similarly s2. So we have the first equation 3x1 plus x3 plus s1 equals to 12, and the second equation we have 2x1 plus 2x2 plus s2 equals to 12. And what we do with the objective function is, here we can see objective function is z equals to 2x1. All the values which are on the right side, we move them towards the left side, that is we move them towards the left side. Therefore this equation becomes minus 2x1 plus z equals to 0. Moving forward, we will form a matrix by using these equations. By using these three equations, we will form a matrix. There are further two methods in simplex method to get the solution. We will see the first method first. Um, let's form a matrix by these three equations. Uh, how we will form a matrix is that we will use the coefficients. Let's say x1 has a coefficient of 3, therefore we will write 3 below x1 in the first row, and x3 has a coefficient of 1, so we will write 1, and x2, so we can see that there is no x2, which means the coefficient of x2 is 0. Similarly, we will write s1, we have one coefficient of s1, therefore we will write 1. And similarly for others, and the constant side we can see there it is 12, therefore we will write 12. Similarly, the second equation we will replace the coefficients, therefore we will get these values x1 2, x2 2, x3 we have no value of x3, therefore we will write it 0. Similarly s1, and the coefficient of s2 is 1, and the constant is 12 again. We will write the objective function, therefore the values will become these. Now we will identify the basic variables. What are basic variables? Basic variables are those variables which have only one non-zero value. For example, we have x3. We will mark it as a basic variable. Why? Because it has only one non-negative value. As we can see, it has only non-zero value 1, and other values are 0. Similarly, we have another select variable s1, and similarly x2, and similarly z. As we can see, x2 is not a select variable, basic variable, because it has x2 is also a basic variable, and x1 is not a basic variable. Moving forward, we will use these basic variables to solve further. As we can see, x2 has coefficient 2, and its corresponding constant is 12. So we will use these which will give us the equation 2x2 equals to 12, and here from here we can get the solution x2 equals to 6. Similarly, we will use coefficients and their corresponding constants. X3 has a coefficient of 1 and its corresponding constant is 12. Therefore, x3 is equals to 12, and similarly we will get x1, s2, z, and x1 and those values which are not basic variables, we will place them equals to 0. As we can see here, uh, x1 is not a basic variable, but therefore we have placed is equals to 0. So the result from the first method, we will get x1 equals to 0, s1 equals to 12, x2 equals to 6, s2 equals to 12, x3 equals to 12, and z equals to 0. Moving towards the second method, the equation which we have formed in the first method will be same. We will get this matrix from the previous method, and now we will identify the pivot. How we will identify? We will first of all observe the baseline. This is the baseline below this line. First of all, we will observe the baseline. Wait a second. First of all, we will observe the baseline. In baseline, we will search for the least value. Here we can see the least value is -2, and in the baseline column above the least value, we will search for the corresponding constants and divide them with the coefficients, and the least value will be giving us the pivot. Let's say we will select this value. The corresponding constant is 12, the coefficient is 2, so we will divide 12 by 2, we will get 6. And similarly for this value, this row, the corresponding constant is 12 and the coefficient of x1 is 3, we will get 4. So what is the least value? We got the least value from by means of 3, so therefore the pivot will be 3. Then we will apply the row operations to make all the values other than 3 in this column equals to 0. So let's apply. The first row operation we will apply will be minus twice of r1 plus thrice of r2. We will add them. Let's take a deeper look. After multiplying the first row with -2, we will get this row, and after multiplying the second row with +3, we will get this. By adding them, we will get a sum of this. Therefore, we will replace this with the second row, and similarly we will do with the third row, which is the baseline. Now let's towards the second operation. As we can see, we have multiplied. The second operation will be 2r1 plus thrice of r3. So we have multiplied row 1 with 2. The result will be this, and row 3 with 3. Then the result will be this. By adding these results, we will get this result. Replacing this result in the matrix, we will now we will identify the basic variables again, as we have identified in the method 1. First of all, what is a basic variable again? Basic variable is the variable which has only one non-zero value in its column. Here we can see x1 is a basic variable because it has only one non-zero value, which is 3. Similarly, x2 is a basic variable. X is not a basic variable because it has more than one non-zero values. S1 is not a basic variable, S2 is a basic variable, and similarly Z is a basic variable. Now as we have done previously, we will replace we will make these coefficients equals to their corresponding constants. Therefore 3x1 will be equals to 12. Therefore we will get x1 equals to 4. Similarly, we will get x2 equals to 8 by using this method, and the coefficient of s2 is 6. Therefore we will get 8 the value of s1 s2, and z has a coefficient of 3 and its corresponding constant is 24. Therefore we will get z equals to 8. And those variables which are not basic variables, as we have done previously, we will place them equals to 0. Therefore we will have the result x1 equals to 4, s1 equals to 0, x2 equals to 8, s2 equals to 8, x3 equals to 0, and z equals to 8. Thank you.